All right, so we're diving into some serious data today.
Oh, yeah.
This academic textbook you sent over about advanced database management systems.
Okay.
We're not just talking about storing data here,
Right.
but how to design these systems, how to implement them, how to secure them.
It's all of the world.
These massive systems.
Oh, yeah.
It's like anyone can stack a few bricks,
Hmm.
but to build a skyscraper, you need a blueprint, a plan.
Absolutely.
And that's what we're looking at today, the blueprint of the digital world.
You got it.
So what I'm already seeing in this textbook is they talk about something called the database development life cycle.
Okay.
So it's like building a skyscraper. There's a roadmap, a process.
Yeah, and it all starts with understanding the lay of the land.
Okay.
The database initial study is kind of like that architect meeting with the client for the first time, and they're figuring out
Getting the requirements.
what the company needs, what problems they're trying to solve, what limitations exist.
I see.
Really setting the stage for a successful project.
So it's not just about the technical stuff,
Right.
but really about aligning the database with the goals of the business.
Exactly.
That makes sense.
Yeah.
So then we move into what's called the database design phase.
Right.
And this is where those requirements get translated into an actual blueprint, a technical blueprint.
Precisely.
So we're defining the tables, the relationships, the data structures, like it's the foundation of our digital skyscraper.
It is. It's the foundation. It's how all the data is going to fit together.
So then we move from the blueprint into actual construction.
Yeah.
This is the implementation and loading phase.
Right. Time to get our hands dirty.
Yeah. So we're installing the software, we're building the database, we're starting to populate it with data.
Yeah, we're putting those bricks in place one by one.
It's getting real now.
It's coming to life.
But before we open the doors to our skyscraper,
Of course.
we've got to make sure everything works.
Yeah.
So this is where we get into the testing and evaluation phase.
So important.
So we're rigorously testing the database, finding and fixing any bugs, making sure the performance is good, security is up to par.
Making sure there are no leaks, no faulty wiring, making sure it's safe and sound.
Yeah, you want to be sure it's rock solid before you go live.
Absolutely.
And then comes the grand opening operation phase.
The database is up and running, supporting the company's needs.
Doing its job.
All right.
But just like a real skyscraper, the work doesn't stop there.
No.
We have the maintenance and evolution phase.
Oh, this is so crucial.
This is where we're keeping the database running smoothly, adapting to any changing needs.
Backups, security updates, performance tuning, maybe even making some structural changes.
So it's a continuous cycle of improvement and adaptation.
It's like keeping that skyscraper functional and modern for years to come.
This textbook really emphasizes how crucial that is for success.
It is. It's the long game.
But here's where it gets even more interesting.
Oh.
They talk about distributed database management systems. Now, are these as complex as they sound?
They can be, but think of it this way. Instead of having all your company's data in one giant skyscraper, you have multiple branches in different cities,
Okay.
each with access to the information they need.
So instead of everything centralized,
Right.
the data is spread out.
Exactly. That's DDBMS in a nutshell, distributing data across multiple locations.
So what's the advantage of doing it this way?
Well, for starters, scalability.
Okay.
As your data grows, you can simply add more nodes to the system.
Right.
Like constructing new skyscrapers as your company expands.
Makes sense.
It's much more efficient than trying to cram everything into a single massive building.
So much more manageable.
Yeah,
But wouldn't security be a bigger concern if your data is spread out like that?
that's a valid point, and we'll definitely dive into security later.
Okay.
But another big advantage of DDBMS is fault tolerance.
Oh, okay.
So if one site experiences an outage, like say a power failure in one of your skyscrapers,
Right.
the other sites can continue operating.
So you're not completely shut down.
Exactly. Uninterrupted access to data is crucial for businesses, especially those running those mission-critical operations.
Yeah, that makes a lot of sense.
Yeah.
But how does the data actually get distributed? Like, are there different ways to do that?
Absolutely. There are several distinct types of DDBMS, each with its own approach to managing that distributed data.
Okay.
The first two, homogeneous and heterogeneous, really focus on the underlying technology.
Right.
So in a homogeneous system, all the sites use the same database management software.
Oh.
Think of it like everyone in your company using the same operating system.
Right.
Things tend to run a little more smoothly that way.
Yeah, so it makes sharing and collaborating easier.
Exactly.
So then a heterogeneous system would be the opposite, where different sites are using different software.
Exactly. This offers more flexibility.
Okay.
It can create some integration challenges,
I see.
which is where federated DDBMS comes in.
I see.
It connects independent databases, allowing them to be managed together.
Like different departments within a company?
Yes, coordinating their efforts.
Gotcha. So then we have replicated DDBMS.
Okay.
That sounds like it's focused on redundancy, like having backup copies of your important files in different locations,
Exactly.
just in case something happens.
In a replicated system, data is copied across multiple sites.
Right.
So even if one site goes down, the data remains accessible.
So it's all about that peace of mind.
Exactly.
So we've got different systems for sharing and replicating data. What about dividing up the workload?
You're thinking along the right lines.
Did that come into play?
That's where partition DDBMS comes in.
Okay.
Imagine dividing a large project into smaller, manageable chunks,
Right.
with different teams responsible for each part.
Okay.
In a partition system, the database is divided into distinct parts, and each site manages a specific portion.
So it's like delegating tasks and responsibilities
Precisely.
across different sites.
Yeah.
Okay, and then finally we have hybrid DDBMS. I'm guessing that combines elements of all these different types.
You got it. A hybrid system takes the best of all worlds,
Right.
allowing for customized solutions that meet the needs of those complex environments.
Like having a team of specialists, all with their own expertise, coming together.
Exactly.
Wow, it's amazing how much thought goes into distributing this data effectively.
It's a whole science.
But I'm curious about how the data itself is organized within these systems.
Okay.
The textbook mentions something called levels of data and process distribution.
Right.
And they use a candy analogy that sounds intriguing.
Oh, yes. The candy analogy is a great way to visualize this.
Okay.
Imagine you have a big bag of candy to share with your friends. If you keep all the candy in one jar, and you're the only one who can organize and distribute it,
Right.
that's like single-site processing, single-site data, or SPSD.
Okay.
All the processing and data management happens on one central computer.
So SPSD is like our centralized candy jar. Simple, but potentially inefficient if you have a lot of candy
Or data.
to manage.
Right.
Now, imagine distributing the candy into separate jars for each of your friends, but you still control the organizing and the distributing.
Okay.
That's multiple site processing, single site data, or MPSD.
Right. You're spreading out the processing power.
Right.
But the data itself remains centralized.
So we're getting a little more organized,
Yeah.
but the friends still rely on you to manage their candy.
That's right.
What if we want to give them more control over their own stash?
That's where multiple site processing, multiple site data, or MPMD comes in.
Okay.
Each friend has their own jar and is responsible for organizing and distributing their own candy.
So everyone has autonomy over their own portion.
Exactly. True data and process distribution.
I love that analogy.
It's a good one.
It makes things so much clearer,
It does.
but it's making me hungry.
Oh, yeah, me too.
So I'm going to move on before I get sidetracked.
Okay.
There's another big shift I see in this textbook. They start talking about object-oriented database concepts.
Right.
So what exactly is object-oriented programming, and how does that relate to databases?
Well, object-oriented programming, or OOP, is a way of designing software that focuses on, well, objects.
Okay.
Imagine your data as this collection of interacting objects,
Okay.
each with its own unique identity
Right.
and a set of behaviors it can perform.
I see.
Think of a real-world object like a car.
Okay.
It has properties like its color, make, and model, and it can perform actions like accelerating, braking, turning.
Right.
In OOP, we represent data in a similar way.
So instead of thinking of data as rows and columns in a table,
Exactly.
we're thinking of it as these interactive objects.
You got it.
So what are some of the key concepts behind this approach?
OOP has 4 main pillars: encapsulation, abstraction, inheritance, and polymorphism.
Okay, that's a lot to unpack.
It is, but we can take it one by one.
All right, let's start with encapsulation.
Encapsulation is like a capsule containing medicine. You don't need to know how it works internally, you just take it as directed.
Right.
In OP, encapsulation bundles data and methods together, hiding the internal details and providing controlled access through those well-defined interfaces.
So it's about simplifying things.
Exactly.
Focusing on the essential information.
Right.
Hiding all that unnecessary complexity.
Exactly, like using a map to navigate a city.
Okay.
You don't need to see every single building and street, just the landmarks and routes.
So that's abstraction in a nutshell.
You got it.
Then we have inheritance.
Right. Inheritance allows you to create new objects based on existing ones,
Okay.
inheriting their properties and methods.
So you're building upon what's already there.
Exactly. It's like designing a specialized type of vehicle based on a general car design.
I see.
You inherit the basic features, but can add your unique customizations.
So inheritance promotes code reuse.
It does.
Creates a hierarchy of objects.
Exactly.
Makes everything more organized and efficient.
It's a powerful concept.
And finally, we have polymorphism.
Yeah. A bit of a tongue twister, but it's a powerful concept.
I'm intrigued. Break it down for me.
Think of an actor playing different roles in a play.
Okay.
They can adapt their behavior to fit each character, right?
Right.
In OOP, polymorphism allows objects to take on multiple forms and behave differently depending on the context.
So they're adaptable and versatile.
Exactly.
These concepts seem incredibly useful for creating these flexible and adaptable database systems.
They are.
But what about object identity?
Okay.
What makes an object unique in this object-oriented world?
Object identity is crucial.
Okay.
It's what distinguishes one object from another, even if they have identical properties.
Oh, I see.
Think of two identical cars again.
Okay.
They might be the same make, model, and color, but they still have those distinct vehicle identification numbers, VINs, that differentiate them.
Right.
In OOP, each object has a unique identifier, regardless of its data.
So it's not just about the information an object holds,
Right.
but about its inherent uniqueness.
Exactly.
I can see how that would be important for managing these large amounts of data.
It is.
But with all this talk about complex systems and unique identifiers,
Yeah.
it makes me wonder about security.
Of course, a crucial consideration.
The textbook mentions database security issues.
Right.
What are some of the biggest threats to these systems?
Well, the text highlights three major threats: loss of integrity, loss of availability, and loss of confidentiality.
Okay, let's break those down.
Okay. Loss of integrity means unauthorized changes to data, compromising its accuracy.
Okay.
Imagine someone tampering with medical records or financial transactions.
Right.
That could have serious consequences.
Yeah, that's a scary thought.
It is. Protecting data integrity is paramount.
So what about loss of availability?
Loss of availability occurs when authorized users can't access the data they need.
Okay.
Think of a hospital system going down during an emergency, or a bank system's going offline on a busy day.
Yeah, those are situations you definitely want to avoid.
Absolutely. These situations can be critical.
And what about loss of confidentiality?
Loss of confidentiality happens when sensitive data gets into the wrong hands.
Right.
This could be anything from personal information like social security numbers and credit card details to confidential business data like trade secrets.
Data breaches are a huge concern these days.
They are, and the damage they can cause is immense.
So how do we protect against these threats?
Well, the first line of defense is access control,
Okay.
restricting access to data based on user privileges and roles.
Right, so only authorized users can access the data.
Exactly. Think of it like having different levels of security clearance.
Okay,
Only those who need it can access certain information.
makes sense.
There's discretionary access control, or DC, where the data owner decides who has access.
Like giving someone a key to your house.
Exactly.
So DC is all about putting the control in the hands of the owner.
Right.
What are some of the other types of access control?
We also have mandatory access control, or MACIT. This is where access is determined by system-defined rules based on those security classifications.
So it's not up to the individual.
Right. Think government security clearances.
I see.
It's not up to the individual data owner, but a central authority.
And then there's role-based access control,
Or BAC.
where you're assigning permissions based on job roles within an organization.
Exactly. So an administrator would have more access than an editor or a viewer.
That seems like a very practical approach.
It is. It aligns with how most organizations operate.
Okay, so what are some of the other security measures discussed in the textbook?
Well, there's inference control.
Inference control.
This is about preventing users from deducing sensitive information indirectly, even if they don't have direct access to it.
So like preventing someone from piecing together a puzzle.
Exactly, even though they're missing some pieces.
So preventing those clever deductions that could reveal confidential information.
Right.
Then there's flow control.
Yes, flow control focuses on preventing unauthorized information flows between different security levels.
So it's like checkpoints.
Exactly.
Between different areas, making sure information stays where it belongs.
You got it.
And finally, we have encryption,
Absolutely essential.
which seems like a core part of any security strategy.
It is. Encryption scrambles data, making it unreadable without the proper key.
It's like putting a lock on a safe.
Exactly. Only those with the key can access the contents.
So encryption basically makes the data unintelligible to anyone without the key.
That's the idea.
But the textbook mentions different types of encryption.
Right.
What's the difference between symmetric and asymmetric encryption?
With symmetric encryption, the same key is used for both encrypting and decrypting the data.
Well,
Think of it like using the same key to lock and unlock a door.
right.
The challenge is securely sharing that key with anyone who needs to access the data.
I see. So asymmetric encryption solves this by using different keys.
Exactly. A public key for encryption and a private key for decryption.
So the public key can be shared freely,
Right.
but only the private key can decrypt the data.
That's the beauty of it.
That's clever.
It's like sending a secret message that only the intended recipient can read.
I like that.
Yeah,
So asymmetric encryption is all about that added layer of security.
it is.
But how do we manage all these keys and certificates?
That's where public key infrastructure, or PKI, comes in.
Okay, so PKI is like a system for managing all these different keys and certificates.
Exactly. It's a framework for managing digital certificates and public keys, enabling secure communication and identity verification.
So it's like a digital passport system.
Yes, verifying the identities of users and devices.
Okay, so PKI is all about establishing trust in the digital world.
It is. It's the foundation of trust online.
It's fascinating how much complexity is involved in just making our online interactions secure.
It is. It's a whole world unto itself.
Now, this textbook doesn't just cover these general database concepts and security.
Right.
It also goes into some specialized databases. I'm particularly intrigued by spatial databases.
Okay.
What are they all about, and why are they becoming so important?
Spatial databases are designed to handle geographic data.
Okay.
They store and query information about locations, shapes, and relationships of objects in space.
So it's not just about numbers and text.
Right.
It's about understanding where things are,
Yeah.
how they relate to each other spatially.
Exactly. Think of a map with points, lines, and polygons representing different features.
Like cities, roads, and parks.
Exactly.
So a spatial database can store all this information and allow you to perform complex queries.
It's like having a digital atlas that you can search and analyze.
Instead of just looking at a static map, you can interact with the data,
Exactly.
ask questions, uncover hidden patterns.
Yeah, you could ask a spatial database to find all the restaurants within a certain radius of your current location,
Oh, that's cool.
or to identify the areas most affected by a recent natural disaster.
So it's like a virtual map that can answer these complex questions.
It is.
Help us make informed decisions.
Exactly.
What are some real-world applications of this?
Oh, they're used in a wide range of fields, from geographic information systems, or GIS,
Right.
to urban planning, environmental monitoring, logistics, transportation.
Wow.
They're essential for understanding our world and making those informed decisions.
About everything from resource management
Yep.
to disaster response.
Absolutely.
It's amazing how spatial databases are being used to solve real-world problems.
They are. They're not just theoretical concepts. They're having a tangible impact.
That's so cool.
Yeah.
What about multimedia databases?
Okay.
They sound like they could handle even more diverse types of data.
They can. Multimedia databases, or MMDBs, are designed to handle various media types,
Okay.
including text, images, graphics, audio, video, even animations.
It's like a digital library that can store all sorts of multimedia content.
Exactly. Think digital asset management, content streaming, e-learning platforms, entertainment platforms.
It's incredible how much they can handle.
It is. It's a lot of data.
But I imagine managing multimedia data comes with its own challenges.
Oh, absolutely. For starters, storage requirements are a big consideration.
Right, because those files can be huge.
Especially images and videos, they can be quite large compared to traditional text and numerical data.
So storage capacity is a major factor.
It is.
What are some other challenges?
Well, there's the issue of data retrieval.
Okay.
You need efficient indexing and search mechanisms to quickly find the multimedia content you're looking for.
So it's like having a good search engine
It is.
for all this multimedia content.
Exactly. You need to be able to find what you're looking for quickly and easily.
Makes sense.
And then there's the issue of managing all the different file formats and codecs.
Right, because those can vary widely.
They do. And a multimedia database needs to be able to handle these variations to provide a seamless experience for users.
Regardless of what type of content they're accessing.
Exactly.
So multimedia databases are all about managing that complexity
Uh-huh.
and diversity.
In the digital media world.
It's amazing how database systems have evolved to handle such a wide range of data types and applications.
It really is. It's a constantly evolving field.
Now, earlier we touched on the concept of object identity in object-oriented databases.
Right.
Can you elaborate on that a bit more?
Of course.
I'm still wrapping my head around what makes an object truly unique in this world.
Object identity is fundamental in OCOP.
Okay.
It distinguishes one object from another, even if they have identical properties.
Right.
It's not just about the data an object contains, but about its inherent uniqueness.
Okay.
Think of two identical cars again.
Okay, got it.
They might have the same make, model, and color,
Right.
but they still have distinct VINs that differentiate them.
So even if two objects contain the same information,
Exactly.
they still have their own unique identifiers.
Yes, it's like each person having a unique social security number,
I see.
regardless of whether they share the same name or birthday.
So it's essential for maintaining data integrity.
It is.
Ensuring that operations are performed on the correct objects.
Precisely.
This is all so mind-boggling.
It is. It's a lot to take in.
It's incredible how much thought and complexity goes into designing and implementing these advanced database systems.
It's a testament to the ingenuity of computer scientists and engineers.
Pushing the boundaries.
Absolutely.
Speaking of pushing boundaries, let's talk about active databases.
Oh, okay.
The textbook mentions them briefly,
Right.
and I'm curious to know what sets them apart.
Active databases are designed to respond to events or changes in the data automatically.
Okay.
They're like having a smart assistant
Right.
that can take actions based on predefined rules and triggers.
So instead of passively storing data, they
Right.
could actively participate in business processes
Exactly. They're active participants.
and workflows.
Right.
That sounds incredibly powerful.
It is.
Can you give us an example of how that works in practice?
Absolutely. Imagine a database that can automatically send an email notification when a customer places an order, or update inventory levels when a product is sold.
That's incredible.
It's like having a self-managing system
Right.
that can automate tasks and streamline operations.
Yeah, it's like giving the database a brain of its own.
I could say that.
But how do these active databases actually work?
Well, the key lies in those triggers and rules.
Okay.
Triggers are essentially procedures that are automatically executed when certain events occur in the database.
Okay.
For example, you could have a trigger that updates a customer's loyalty points whenever they make a purchase.
So it's like setting up a chain reaction.
Yes, where one event automatically triggers another action.
That's powerful.
It is.
And these triggers can be combined with rules,
Exactly.
which are logical conditions that determine when and how the trigger should be activated. So you're defining the logic and the behavior of the database.
Precisely.
It's like giving the database a set of instructions to follow based on certain conditions.
You got it.
If this happens, then do that.
Exactly.
It's programming the database to be intelligent and responsive.
Active databases are all about that, adding intelligence and automation to data management.
It seems like we've covered a lot of ground already.
We have, from database development life cycles and distributed systems to object-oriented concepts, security measures, and even these specialized databases like spatial and multimedia databases.
But I have a feeling there's still much more to explore.
Oh, there's always more to learn in the world of data.
This textbook also mentions temporal databases,
Okay.
and I'm curious to learn more about those.
All right.
How do they differ from the other types of databases we've discussed?
Temporal databases are fascinating. They can track changes in data over time.
Okay.
Think of them like a time machine for data, allowing you to view historical snapshots and analyze how things have evolved.
That sounds incredible. Can you give us an example of how they're used in practice?
Absolutely. Imagine a bank that wants to track changes in customer account balances over time. A temporal database can store not only the current balance, but also all previous balances, along with the timestamps of when those balances were valid.
So it's like having a complete transaction history for each account.
Right.
You can go back in time and see how the balance has changed.
You can, and this allows the bank to perform queries like, what was the customer's average account balance last year? Or, How has the customer spending behavior changed over the past 5 years?
That's amazing.
It is. It's like having a historical record of the data that you can rewind and replay.
I can see how that would be valuable for analysis,
It is.
trend prediction, even auditing.
Absolutely. Temporal databases are essential for applications that require that historical analysis, trend prediction, and auditing.
So as we generate more and more data over time, their importance is only going to grow.
It is. It's an exciting area of database management.
This has been an incredible journey through the world of advanced database management systems.
It ha-
We've learned about all these different database types, design and development processes, security measures, so much more.
We've covered a lot of ground.
But before we move on, I'm curious to know what stands out to you the most from all this information.
What fascinates me is how far database systems have come
Right.
and how they're constantly evolving to meet the growing demands of our data-driven world.
It is amazing how much innovation is happening in this field.
It is, from basic data storage to these intelligent systems that can adapt and respond to changes in real time. It's truly remarkable.
But what I find most exciting is how these advancements are being applied to solve those real-world problems
Absolutely.
across such a wide range of industries.
It's not just theory, it's making a difference.
Whether it's optimizing business processes,
Right.
managing resources more efficiently, or gaining deeper insights from data, advanced database management systems are really shaping our future.
They are. And as we continue to generate more data, their impact is only going to grow.
This is all so fascinating, but there's one more topic I want to touch on before we wrap up part 1 of this deep dive.
Okay, what's that?
The textbook mentions something called two-phase locking protocols.
Right.
Can you explain what those are and why they're important?
Of course, two-phase locking, or 2PL, is a concurrency control method used in databases to ensure that transactions don't interfere with each other and maintain data integrity.
So it's about preventing conflicts when multiple users are trying to access
Exactly.
or modify the same data at the same time,
You got it.
especially when you have a lot of activity happening within a database.
It's like a traffic cop directing traffic at a busy intersection,
Okay, I like that analogy.
making sure everyone follows the rules and avoids collisions.
So how exactly does 2PL work?
In 2PL, a transaction acquires locks on the data it needs to access,
Okay.
preventing other transactions from modifying it until the first transaction is complete.
So it's like checking out a book from the library.
Exactly.
Once you've checked it out,
Right.
no one else can borrow it.
Until you return it.
That makes sense.
Yeah.
So that's how the locking mechanism works.
Mm-hmm.
But you mentioned there are 2 distinct phases in this protocol.
Right.
Can you explain what those are?
The first phase is called the growing phase, where a transaction can acquire new locks but cannot release any existing locks.
Okay.
It's like gathering all the ingredients you need before you start cooking a meal.
Right.
Welcome back. Ready to dive back into the world of databases.
Absolutely. I'm still thinking about that public key infrastructure, the PKI that
Yeah.
we talked about in the last part.
Oh, yeah. It's a fascinating system.
It is. And I think I get the general concept, but
Love it.
I'm curious to know more about how it actually works in practice. You know,
Right.
like it's one thing to understand the idea, but how does it play out in our everyday,
In the real world.
yeah, like in our digital interactions?
Absolutely. Great question.
So can we break that down a little bit?
Sure. Let's imagine you're visiting a secure website, the ones with the little padlock icon in the address bar.
Right. The HTTPS sites, the ones that are supposed to be more secure.
Exactly. So when you visit one of those sites, your browser actually checks the website's digital certificate.
Okay.
Think of it like an ID card.
So it's verifying that the website is who it says it is.
Precisely. This certificate contains the website's public key, which we talked about earlier,
Okay.
and information about the issuing certificate authority, or CA.
So my browser is basically verifying the website's credentials,
You got it.
making sure it's legitimate.
Exactly. And not some shady imposter.
Right, exactly.
And if the certificate checks out,
Meaning,
it's valid, it's issued by a trusted CA, then your browser will use the website's public key to encrypt any data you send, like your login credentials or credit card information.
so the public key is like a lock,
Exactly.
securing my data before it's sent to the website.
Precisely.
And only the website with the corresponding private key can unlock it.
Right. It's like sending a secret message that only the intended recipient can read.
That's a good way to put it.
It's all about ensuring confidentiality, even if someone intercepts the data during transmission.
So PKI is the backbone of secure online transactions.
It is.
It's amazing how much happens behind the scenes just to protect our online interactions.
It's a complex system, but it's essential for building trust and confidence online.
But I have to ask about those free PKI solutions that the textbook mentioned.
Okay.
Are they as reliable as the paid ones?
That's a valid question.
You often get what you pay for, right?
There's some truth to that, but while paid PKI solutions often offer additional features and support,
Right.
free options can still provide robust security for many applications.
Okay.
It really depends on the specific needs and risk tolerance of the organization.
So it's trade-off
In a way, yeah.
between cost and those additional features.
Exactly.
Are there any free PKI solutions that are considered reputable?
There are.
I'd be a bit hesitant to trust something that's completely free.
I understand the hesitation, but there are some highly regarded free PKI solutions out there.
Okay.
OpenSSL and CFSSL, for example, are widely used and trusted by developers and organizations worldwide.
Okay.
They've been vetted by the community and have a proven track record.
So there are options.
Absolutely. There's a PKI solution out there for every budget and every security requirement.
So we've covered the basics of PKI
We have.
and how it keeps our data safe online.
That's right.
But this textbook also delves into some really interesting specialized databases.
It does.
I'm particularly intrigued by spatial databases.
Okay, what about them?
They sound almost futuristic.
A bit, yeah.
What are they all about?
So spatial databases are designed to handle a special kind of data, geographic data.
Okay.
Think maps, locations, shapes, the relationships between objects in space.
So not just numbers and text,
Right, it's about understanding where things are.
and how they relate to each other spatially.
Exactly, it's like having a digital atlas that you can search and analyze.
Instead of just looking at a static map, you can interact with the data.
Exactly.
Ask questions, uncover hidden patterns.
Yeah, imagine being able to ask a spatial database to find all the restaurants within a certain radius of your current location,
Oh, that would be cool.
or to identify the areas most affected by a recent natural disaster.
So it's like a virtual map that can answer these complex questions.
It is, and help us make more informed decisions.
What are some of the real-world applications of this?
They're used in a wide range of fields, from geographic information systems, or GIS,
Okay.
to urban planning, environmental monitoring, logistics, transportation.
I'm seeing used everywhere.
It really is. It's essential for understanding our world and making informed decisions about everything from resource management to disaster response.
It's amazing how spatial databases are being used to solve those real-world problems.
They are. They're not just theoretical concepts.
They're making a real difference.
Absolutely.
And what about multimedia databases?
All right.
Those sound like they could handle even more diverse types of data.
They can. Multimedia databases, or MMDBs, are designed to handle a wide range of media types: text, images, graphics, audio, video, even animations.
So we're talking about storing and managing images, videos, music, all that.
Exactly. Think of them like digital libraries that can store and manage all sorts of multimedia content.
Like having a giant multimedia archive.
Exactly. And they're essential for applications like digital asset management, content streaming, e-learning platforms, entertainment platforms.
They're what make it possible to access all that content.
Exactly. On demand.
It's incredible how much data they can handle.
It is.
But I imagine managing multimedia data comes with its own unique challenges.
Oh, absolutely. For starters, storage requirements are a big consideration.
Right, because those files can be huge.
They can be, especially high-resolution images and videos. They take up a lot of space.
So storage capacity is a major factor.
It is.
What are some other challenges?
Well, there's also the issue of data retrieval.
Okay.
You need efficient indexing and search mechanisms to quickly find the content you're looking for.
Right, so it's like having a good search engine.
It is for your multimedia content.
You need to be able to find what you're looking for quickly and easily.
Exactly.
And then there's the issue of all the different file formats and codecs,
Right, that's another big one.
because those can vary widely.
They do.
So a multimedia database has to be able to handle that,
It does.
to provide a seamless experience for users.
Exactly, regardless of the file format.
So multimedia databases are all about managing that complexity and diversity.
Yeah, in the world of digital media.
Okay, so we've got spatial databases
Right.
that help us understand our world geographically.
Exactly.
Multimedia databases that handle our ever-growing collection of digital media.
That's right.
But this textbook also spends quite a bit of time on object-oriented databases.
It does. It's a key concept.
We touched on them earlier,
Yeah.
but I'd love to dive a little bit deeper into that concept of object identity.
Okay. What about it?
It's such a fundamental concept, but it's still a bit abstract for me.
I understand. Object identity is really key in object-oriented programming.
Okay.
And it's what makes each object unique and distinguishable, even if they have the same data.
Oh, give me an example.
Sure, think of it like this. You and I could both have a car that's the same make, model, and color.
Okay.
But they're still distinct entities, right?
Right.
Because they have different vehicle identification numbers, VINs.
So even if two objects look identical, they still have their own unique identifier that sets them apart.
Exactly.
And in the world of databases, this is really important
It is.
for maintaining that data integrity
Absolutely.
and making sure that the right actions are performed on the right objects.
Precisely. It's like having a unique social security number for each object in the database.
Oh, okay, that makes sense.
So even in a database with millions of objects, each one has its own unique identifier.
Like a fingerprint.
Exactly. That distinguishes it from all the others.
Okay, that helps clarify things a bit.
Good.
So object identity is all about uniqueness, ensuring that each object in the database is treated as a separate, distinct entity.
Exactly.
Even if it shares data with other objects.
Right. It's about maintaining that individuality.
It's fascinating. It's like giving each piece of data its own personality.
In a way, yeah.
Okay, so we've got object identity sorted out.
We do.
Now, what about active databases?
Oh, yeah. Those are interesting.
We touched on them briefly earlier, but
you want to go deeper?
yes, they sound incredibly powerful, almost futuristic.
They are pretty amazing.
So tell me more.
Active databases are designed to respond to events or changes in the data automatically.
Yeah.
They're like having a smart assistant that can monitor the data
Right.
and take action when certain conditions are met.
So they're not just passively storing data.
Right. They're actively participating in the processes and workflows that rely on that data.
That's right.
Exactly.
So give me an example.
Sure. Imagine a database that can automatically send an email notification when a customer places an order, or adjust inventory levels when a product is sold.
That's incredible. It's like having a self-managing system.
It is. It can automate tasks, streamline operations.
It's like giving the database a brain of its own.
You could say that.
But how do they actually work?
Well, the key lies in the use of triggers and rules.
Okay, so triggers are...
Triggers are essentially procedures that are automatically executed when certain events occur in the database.
Okay, so if this happens,
And this happens.
it's like a chain reaction.
Exactly. One event triggers another action automatically.
And these triggers can be combined with rules
Right.
to add even more control.
Exactly. Rules are logical conditions that determine when and how the triggers should be activated.
So you're defining the logic,
Uh-huh.
the behavior of the database.
Precisely. It's like giving the database a set of instructions to follow based on certain conditions.
So if this happens,
Then do that.
it's programming the database to be intelligent
Uh-huh.
and respond.
Exactly. Active databases are all about adding that intelligence and automation to data management.
It's like taking databases to a whole new level.
It is.
As our world becomes more and more data-driven,
Right.
active databases are going to play an even more important role
They are.
in automating tasks, streamlining processes, making better decisions.
Absolutely.
It's fascinating to think about all the possibilities.
It is. It's an exciting area of database management.
Okay, so we've explored spatial databases,
Yes.
multimedia databases,
Uh-huh.
object-oriented databases,
Right.
and active databases.
A lot of ground covered.
This textbook is packed with information.
It is. It's a comprehensive resource.
But there's one more type of database I'd love to discuss.
Okay, which one?
Before we wrap up this part of the deep dive,
All right, shoot.
the textbook mentions temporal databases.
Okay.
And I'm curious to know more about those.
Sure, what about them?
How do they differ from the other types of databases we've discussed?
Temporal databases are fascinating. They're designed to track changes in data over time.
I'm especially interested in their connection to time.
It's right there in the name.
So tell me more.
Think of them like a time machine for data, allowing you to view historical snapshots and analyze how things have evolved over a period of time.
So it's not just about storing the current state of the data.
Right.
It's about capturing the entire history of the data.
Exactly, with timestamps and everything.
Can you give me an example of how that works in practice?
Absolutely. Imagine a bank that wants to track changes in customer account balances over time.
Okay.
A temporal database can store not only the current balance, but also all the previous balances,
Okay.
along with the dates and times when those balances were valid.
So you could essentially rewind the clock and see how a customer's account balance has fluctuated
Exactly.
over time.
That's the power of temporal databases.
That would be incredibly valuable for analysis, trend prediction, even auditing.
It is. You can see how things have changed over time.
It's like having a historical record of the data.
It is. You can rewind and replay.
So temporal databases are all about capturing that flow of time and providing insights into how things have changed.
Exactly.
They're being used in finance and healthcare, scientific research, historical analysis.
All sorts of fields.
It's amazing.
It is. And as we generate more and more data, temporal databases will become even more important.
For understanding the past, making sense of the present,
and predicting the future.
Absolutely.
They're a powerful tool.
This has been an incredible journey.
It has.
Through the world of advanced database management systems.
Let's cover a lot of ground.
We've covered so much, from the fundamentals of database design to the complexities of distributed systems, specialized databases, all kinds. Spatial, multimedia, object-oriented, active, temporal.
There's been a whole universe of data management.
I feel so much more informed about this field.
Good. I'm glad to hear that.
But before we wrap up this part,
okay,
I'd love to hear your thoughts on what stands out to you the most from all this information.
What strikes me the most is the sheer diversity and ingenuity of the systems we've discussed.
It is amazing.
It is. From databases designed to handle geographic data to those that can manage multimedia content.
Right.
From those that model real-world objects to those that can respond to events in real time, it's clear that database management is a field of endless possibilities.
And it's constantly evolving.
It is.
To meet the needs of our data-driven world.
It has to.
But what I find most exciting is how these advancements are being applied to solve real-world problems.
Absolutely.
Across such a wide range of industries.
It's not just theory, it's making a tangible impact.
Whether it's optimizing business processes, managing resources more efficiently, or gaining deeper insights from data, advanced database management systems are playing a vital role in shaping our future.
They are, and as we generate more and more data, their impact will only continue to grow.
It's an exciting time to be involved in this field.
It is. The future of data management is full of potential.
I agree. But before we get ahead of ourselves, let's take a closer look at one of the concepts we touched on earlier.
Right.
Two-phase locking protocols.
Yes, 2PL.
The textbook goes into quite a bit of detail.
It does.
About these protocols, and I'd like to unpack them a bit more.
Sure, happy to delve deeper.
So, to remind our listeners, two-phase locking, or 2PL, is a concurrency control method used in databases to ensure that transactions don't interfere with each other.
Exactly. It's all about maintaining data integrity.
So it's about preventing those conflicts that can happen when you have multiple users trying to access or modify the same data
at the same time.
Simultaneously.
Exactly, especially when you have a lot of activity happening within a database.
It can get chaotic.
It can.
So how exactly does 2PL work?
In 2PL, a transaction acquires locks on the data it needs to access, preventing other transactions from modifying that data until the first transaction is complete.
Okay, so walk me through that.
Sure, it's like checking out a book from the library.
Okay.
Once you've checked it out, no one else can borrow it until you return it.
So that's how the locking mechanism works.
Exactly. It prevents multiple users from modifying the same data at the same time.
Otherwise, you could end up with all sorts of inconsistencies.
You could, and errors.
2PL helps avoid those problems.
It does.
By ensuring that only one transaction can modify a piece of data at a time.
Exactly. It's like having a controlled environment.
Okay, so that's the basic idea. But you mentioned earlier that there are two distinct phases in this protocol.
There are.
Can you explain what those are?
The first phase is called the growing phase, where a transaction can acquire new locks, but cannot release any existing locks.
So it's like gathering all the ingredients you need before you start cooking.
Exactly. You wouldn't want to start cooking and then realize you're missing a key ingredient.
Right. You need to have all your resources in place before you can begin working on the data. So what happens in the second phase?
The second phase is called the shrinking phase, where a transaction can release locks, but cannot acquire any new ones.
So it's like finishing your meal and then washing the dishes and putting the ingredients away.
Exactly. You've completed the task and you're freeing up those resources for others to use.
So once you're finished working with the data, you release the locks.
That's right.
Allowing other transactions to access it.
Exactly.
But are there different types of 2PL protocols?
There are. There are actually several variations, each with its own characteristics and benefits.
So it's not a one-size-fits-all approach?
Not really, but instead of getting bogged down in the technical details, let's focus on the core concept. 2PL is all about preventing conflicts and ensuring data integrity.
Okay.
When you have multiple transactions happening at the same time.
Concurrently.
Right. It's like a set of rules that keeps everything running smoothly in a busy database environment.
I appreciate you keeping it high level.
Sometimes it's good to step back and see the big picture.
It's easy to get lost in the technical details, but I think it's important to understand the overall purpose and benefits
of these protocols.
Now, the textbook also mentions three-phase commit protocols.
Right. 3PC.
Which sound even more complex.
They are a bit more complex.
Can you give us a quick overview before we wrap up this part?
Of course, three-phase commit, or 3PC, is a more complex protocol that's designed to handle distributed transactions where data is spread across multiple systems.
So it's like coordinating a group project.
It is, where different team members are working on different parts from different locations.
And you need to make sure that everyone is on the same page.
Exactly.
And that the project is completed successfully.
Even if some members drop out or encounter problems.
So it's about coordinating transactions that involve multiple databases or servers.
It's all about ensuring that everyone is in sync.
Okay.
And that the transaction is completed successfully, even if there are failures along the way.
That sounds challenging.
It definitely can be.
But that's what 3PC is designed to do.
It is. It's an extension of two-phase commit, or 2PC,
Right.
but with an additional phase to prevent blocking.
Blocking.
Yeah, which can occur when a coordinator fails during a transaction.
So it's like having a backup plan in case the project leader suddenly becomes unavailable.
Exactly. You need someone else to step in and make sure the project stays on track.
So you're adding an extra layer of protection to ensure the transaction can still be completed.
Even if there are unexpected disruptions.
That makes sense.
The third phase in 3PC ensures that at least a certain number of participating sites are aware of the coordinator's decision to commit the transaction, even if the coordinator fails.
So it's like having a consensus among the team members.
Exactly, so that the project can move forward even if the leader is absent.
Right. You don't want the whole project to grind to a halt just because one person is unavailable.
Exactly. 3PC helps to avoid that.
So 3PC is all about adding that resilience and fault tolerance
to distributed transactions.
It's incredible how much thought goes into designing these protocols.
It is a lot of clever engineering.
To ensure that data remains consistent and reliable.
Absolutely.
Even in these complex and distributed environments.
It's a testament to the importance of data management in today's world.
Okay, so we've covered the basics of two-phase locking and three-phase commit protocols.
We have.
They're both designed to handle concurrency and ensure data integrity.
Right.
But they differ in their complexity and the types of transactions they're best suited for.
That's right.
2PL is like a traffic cop, directing traffic at a busy intersection.
I like that analogy.
While 3PC is more like a sophisticated air traffic control system.
Coordinating flights across multiple airports.
That's a great way to think about it.
It highlights the fact that there's no one-size-fits-all approach to data management.
Right. The best approach depends on the specific needs of the application and the environment.
Exactly.
This has been an incredible deep dive so far.
It has been a lot of information.
We've explored so many different aspects of advanced database management systems.
We have, from the fundamentals of database design to the complexities of distributed systems and specialized databases.
I'm already feeling much more informed about this field.
It's great to hear.
But before we move on to part 3 of our deep dive, I'd love to hear your thoughts on what you think is the most important takeaway.
Okay, if I had to choose one key takeaway, it would be this. Data is everywhere, and it's only becoming more pervasive and essential to our lives.
It really is.
Understanding how to manage it effectively, how to design and implement robust and secure systems, how to leverage the power of specialized databases, and how to keep up with the ever-evolving landscape of data management is critical.
It's such a crucial skill.
It is in today's world.
It resonates with me because we live in a world where data is transforming everything.
It is. It's changing the way we work, communicate, learn, make decisions.
It's more important than ever to be data literate.
Absolutely.
And to have a basic understanding of how these systems work.
I couldn't agree more. Data literacy is a fundamental skill for the 21st century.
And I think this deep dive is a great step in that direction.
It is. It's a great introduction to the world of advanced database management.
It's been an eye-opening experience for me, and I'm sure our listeners are feeling the same way.
I hope so. And I'm excited to continue this journey with you in part 3 of our deep dive.
Me too. So to our listeners, stay tuned for the final part of our exploration of advanced database management systems.
We'll be back soon with more insights and discoveries.
Until then, keep exploring the fascinating world of data. Okay, so we're back for the final part of our deep dive into advanced database management systems. We've covered so much ground already, but I feel like there are a few more nuggets of wisdom in this textbook just waiting to be unearthed. What do you think?
Oh, absolutely. There's always more to uncover when it comes to databases. What's caught your eye?
Well, earlier we were discussing those concurrency control methods, right?
Yeah.
The ones that ensure multiple transactions can happen without creating total chaos in the database.
Right, like making sure everyone can check out books from the library without stepping on each other's toes.
Exactly. We talked about two-phase locking, 2PL, but this textbook also mentions three-phase commit protocols, 3PC, and honestly, they sound even more intriguing. What's the deal with those?
3PC is definitely a step up in complexity, but it's designed to handle a very specific challenge that pops up in distributed databases. Remember, in a distributed system, your data is spread across multiple servers, maybe even in different locations.
Right, so you've got multiple players involved, which can make coordination a lot trickier.
Exactly. Now imagine you're trying to update some data, but it's not all in one place. It's spread across several of those servers. You need a way to make absolutely sure that all the servers commit those changes together.
Okay.
Or not at all. It's an all or nothing situation. This is called atomicity, and it's a fundamental rule in database transactions.
So either everyone's on board with the changes, or the whole thing gets scrapped to prevent inconsistencies.
You got it. And that's where 3PC comes in. It's like 2PC, two-phase commit, but with an extra layer of protection to handle potential failures, especially coordinator failures.
Okay, so 2PC is the foundation, and then 3PC adds the safety net on top, just in case things go wrong.
Right, because in a distributed system, things can and do go wrong. So what kind of failures are we talking about?
Well, give me an example.
Okay, imagine the coordinator, the one who's like the conductor of the orchestra, making sure everyone's in sync. Imagine it suddenly crashes. Poof, gone.
Uh-oh. So no one's leading the charge anymore.
Exactly. And in a 2PC system, that can cause some serious issues. You might have some servers ready to commit the changes while others are still waiting for instructions from the coordinator. Deadlock.
So everything grinds to a halt because they're waiting for instructions from someone who's no longer there.
Precisely. And that's a recipe for data inconsistencies and all sorts of headaches.
Okay, so that's where 3PC swoops in to save the day.
You got it. 3PC introduces an extra phase, that third phase, specifically to prevent this kind of blocking scenario. It makes sure that even if the coordinator kicks the bucket, at least a certain number of those participating sites are still on the same page.
So even if the conductor disappears, the orchestra can still play together.
Exactly. It adds an extra layer of resilience, making those distributed transactions more robust and way less likely to fail catastrophically.
Okay, so 3PC adds complexity, but it's there for a reason. It's like an insurance policy for those really important transactions.
Right, and it's worth it when data consistency is absolutely critical.
This is all so fascinating. It really highlights the amount of thought and engineering that goes into keeping data consistent and reliable.
Yeah.
Especially in these more complex environments.
Absolutely. As our world leans more and more on data and our systems become increasingly complex, the need for these kinds of robust and sophisticated solutions is only going to become more critical.
I completely agree. This deep dive has been an incredible journey. We've explored the fundamentals of database design, delved into the mind-boggling world of distributed systems, and uncovered the power of all these different specialized databases. Spatial, multimedia, object-oriented, active, temporal, you name it. I feel like I've leveled up my understanding of this field significantly.
That's fantastic to hear. It's been a real pleasure sharing this journey with you. You bring so much curiosity and enthusiasm to this topic, and I'm sure you'll continue to make amazing discoveries as you explore the world of data further.
Thank you. I really appreciate your guidance and expertise, and I know our listeners have learned a lot from you as well. So to everyone who's joined us on this adventure, thank you so much for listening. We hope you've enjoyed exploring the world of advanced database management systems as much as we have.
And remember, the journey doesn't end here. The world of data is constantly changing. There's always something new to learn and explore. Keep pushing those boundaries and see what you can discover.
Until next time.